another. So there is no energy destroyed. If you are converting it from potential energy to kinetic energy, you convert the whole of it. Nothing is left out, or nothing is lost. So it states that energy can neither be created nor destroyed, but it changes from one form to another form. Is this clear? Yes. So if we look at a falling body, if we take an example of a falling body, a body falling freely in the atmosphere, okay? If you have a stone, okay, which is stationary somewhere in the air, when a body is stationary, it has only potential energy. So at that position, it has only potential energy because it is not moving. Am I clear? Now, when it starts falling downwards, it gains kinetic energy. Why? Because it has velocity. Therefore, as it falls, it has both potential and kinetic energy. Potential plus kinetic energy. If this is the ground, when this ball falls until it reaches the ground, when it hits the ground, its potential energy is zero. Because height is zero above the earth. So here, potential energy is zero. The body has only kinetic energy. This therefore implies that a falling body, as it falls, potential energy is reducing, but kinetic energy is increasing. You are converting from potential to kinetic. Am I clear? Yes. And I hope this is what is going to explain. Now, when it hits the ground, this kinetic energy now becomes sound and heat. So, energy is not destroyed. That's what happens on a falling body. Initially, it was potential energy only. When it is falling, you have potential and kinetic. When it hits the ground, it has only kinetic. And then later, it becomes sound and heat. That is the energy conversion which occurs. So, are you look at a swinging pendulum? A swinging pendulum. Have you ever swung a pendulum? When you were young, we used to swing pendulums. When you swing this ball, okay? Like this. At that point where I have put it, it has potential only. Kinetic energy is zero because its velocity is zero. Remember, kinetic energy, the formula has V. So when the velocity is zero, we have only potential energy. So at that point, it is only potential energy. When it begins moving like this, potential energy is being converted into kinetic. When it reaches this point, all potential energy has been converted into kinetic. Then it begins rising. When it begins rising, kinetic energy is being converted into potential energy. When it reaches maximum height here, All kinetic has become potential. Then it comes back. So, as the pendulum is swinging, potential energy is being converted into kinetic energy and vice versa. Am I clear? This is what happens here. So, we assume here it is fixed. Okay?
Yes.
It's not moving. So when you get the pendulum and then swing it in this position. Now, this is expected to be maximum height. At maximum height here, the pendulum is not moving. Okay?
Yes.
And if it is not moving, its potential energy is maximum. Kinetic energy is zero. Remember, kinetic energy is equal to half mv squared. So when V is zero, potential kinetic energy is zero. So at this point, the pendulum bob only has potential energy. Kinetic energy is zero. So when it begins moving downwards, you are converting potential energy into kinetic energy. So between here, it has both energies, potential and kinetic. When it reaches here, all potential energy has become kinetic energy. Why? Because at that point, potential energy is zero. Height is zero. The height here is zero. So when the height is zero, potential energy is zero. Therefore, all potential energy has now become kinetic. Am I clear? Yes. You are converting potential energy to kinetic as it moves down. Now, when it reaches here, kinetic energy is maximum here. But potential is zero. Because height is zero. So it begins moving upwards again. As it goes upwards, height is increasing. When height increases, potential energy increases. Am I clear? So when it reaches here, it has only potential energy. Kinetic energy is zero because velocity here is zero. So on a swinging pendulum, at these ends, we have potential energy only, and here potential energy only. In the middle, we have kinetic energy. In between, both. Have you got it?
Yes.
In between, we have both energies. Here, a swinging pendulum indicates that energy is not destroyed. It is just converted from potential to kinetic, from kinetic to potential. As simple as that. If there is nothing you are asking, we go to something else. Okay, can you people draw that diagram of a swinging pendulum? This one is important. They might bring it.